So, in this date class, there is a static function, static member function, and a static member variable. And that means no matter how many date objects I choose to create, there's only one format object. And when I call the setFormat function, it affects all objects of this type, not just a single object that I call the member function on. Okay. All right. So one of the rules said I have to define it outside of the class, right? Static data members must also be defined globally. So that's what I'm doing here. I define it here, but don't use the static keyword. Okay? See how I defined it? It's type date : format. Format is defined inside of date. That's allowed. Okay. The name of the variable is date : format. It's this format which lives inside of the date class. Equal sign here means initialization. And this is the value, date : American, which is one of the EU values. Okay? All right. Here's the definition of the setFormat function. Looks good. Don't use static here. And so what it's going to do is it's going to set this format here, right? It's not a local variable. So we next check to see if it's a class variable. It is a class variable because there's an object with that identifier inside of the class definition. So we know that this is a class variable format. We set it to a value. You notice that there's only one of them. So exactly as advertised, when I call this function, it affects all of the objects of that type. Okay. All right. Okay, initialization revisited. When does initialization take place? When we create an object like this, we've seen that 100 times, that's initialization. It gets invoked when we pass a value parameter. So in this case, date D is a local variable to the function func, so it gets initialized. And for temporary values, so for something like this, right? Okay. This is going on and on about the copy constructor. A copy constructor is a constructor that is called when a new object is created and initialized with an object of the same class. Looks something like this. So date, const, date, ampersand, and then the identifier for the object. So it's just another constructor. And it takes a reference to an existing object of the same type. All right. Let's look at an example. Here is a copy constructor for date. Copy constructor would be called like this. So here, when we create D1, the default constructor will be called. Here, when we create D2, we're copying D1 into D2. Basically making a D2, which is a copy of D1, copy constructor gets called. Same thing here. Okay. And the same thing here. So make sure you understand what's going on here. So this date object is created. This date D gets constructed from this date object here. Here's an example of an implementation of a copy constructor. So the input object is D. And we might set the year to be the same year as the input D. And for whatever reason I decided to reset the month and day, although normally you'd probably copy that. It'd be d.month, d.day. Okay. Copy constructor is a member of date, so it has access to the private members of any date object. So, just to be clear about this, not only can I access the year, month, and day of the object that I'm being called on, but I can also access that for other date objects. So this is allowed, even if year is private.
Can I ask a question?
Sure.
The assignment when we do today, when we assign yesterday to today, let's say, is it because of the copy constructor, or we can do that although we don't have any copy constructor definition?
So the copy constructor will not be called for assignment, only for initialization. The difference being that initialization happens, maybe I'll just bring up the text. Okay. In this case, this is assignment. So no copy constructor is called.
Okay, and in this case, all the values in E is copied and assigned to D, right? I mean, when
That's
I change
correct.
E, it won't affect D.
That's correct.
Okay.
Everything is copied. When you say when I change E, it doesn't affect D, that is true as long as you're not copying pointers and modifying what the pointers point to. Okay? In this case, just to bring it home, the copy constructor is called because it's initialization. It happens on the same statement that object F is created. Okay?
So what's the difference between using copy constructor and creating an object and then just creating an object and assigning?
The difference is that different functions get called. In this case, the copy constructor gets called. In this case, something called the assignment operator gets called, which is a separate function. And we're going to get to the assignment operator. But basically, you want to write code that does the right thing no matter which method the programmer uses. So the moral of the story is if you want to do the right thing, you have to define the copy constructor to do the right thing. You also have to define this assignment operator to do the right thing. You're certainly welcome to ask the question, why did the C++ designers make their language this way? And I cannot answer that question, but this is how it works.
The second one might be helpful when we have pointer values in the constructor, right? I mean, the copy constructor might be helpful in that case. Or
Yes, in fact, when you have pointers, like let's say the date class has pointers, then you have to decide how your date object behaves. Do you want to copy the pointers because it's fast? Or do you want to be safe and do you want to like make a copy of the structure that's being pointed to? And that's up to you as a designer to make that choice. Okay. I think we're going to do more copy constructor stuff. So, overloaded operators. An overloaded operator is an operator that has been defined to operate on class objects. The operator invokes a special function called an operator function in order to evaluate the expression. And this is what the operator function looks like. The hash symbol here is meant to be the symbol of the operator that we wish to overload. So it could be plus, minus, multiplication, division, assignment, and so on. So to overload the addition operator, your function name would be operator plus. Okay. So for now, we will only consider overloaded operators that are member functions. For member functions, binary operators have one argument. Unary operators have no arguments. Okay. A binary operator is like A plus B. Unary operator would be like negative C. Alright. So here's an example. In our date class, this would be overloaded operator. And then these would also be overloaded operators. This would allow us, for example, to, I don't know what adding two dates together means actually, but I could imagine subtracting dates, right? And that would give you the number of days different